moving on and looking at the effects of global warming, we talked about sea level rise. So now a little bit different, talking about the sea. We have ocean currents, and while we haven't gone over ocean currents in a lot of detail, one ocean current that you definitely need to know is the Gulf Stream here along our coast. And so if you look at ocean currents, you have this warm water at the equator that moves up, around, up the coast, all the way up into the Arctic water. It's cooling down and coming back down. And so what's happening is that warm water rises and it moves its way north. And as it's cooling down, it sinks and falls and comes right back down to the equator. And so it is a current. It's a cycle. And on the surface, these currents are also aided by the wind, and so this is where we get these kind of movements of water from. And so there is a possibility that if we have warmer Arctic temperatures, that these, or warmer temperatures overall, really, right? But more importantly, these northern Arctic temperatures are rising, and so the water won't be as cold. If the water isn't as cold, then these ocean currents can kind of slow down and pause, because it's all about density, and so the cold water is denser, and that's what's causing the movement in the ocean. If the water doesn't cool down enough, then hopefully, obviously, well, not hopefully, right? But obviously, I would hope, that sounds better, that you can see that these ocean currents are not going to occur in the way that they have been. And so that can have major ecological impacts. And so another thing that can actually slow or disrupt the ocean current is the increase of fresh water into the system. And so as my polar ice caps are melting, right, this freshwater influx can actually, freshwater influx is actually making the water less dense. And so again, those that water won't fall and sink to the bottom and move towards the equator. And instead, right, it'll kind of be stagnant up in the Arctic, because that water is not as dense as it needs to be to sink and move. And so this melting ice from the polar ice caps, like I said, and also increased rain events from this climate change that we're experiencing. And so here's a larger picture of this if you want to take a look at it. Again, here's normally how currents work. We have the sun is heating the water in the tropics, which ends up moving the water north. And then as the water cools, it falls. And then as it falls, it moves back towards the equator. Where here, if you have an increased rainfall, you end up with a less dense water. And so this water actually has nowhere to go from the equator. So because this water actually isn't moving in to the equator from the Arctic. Excuse me. Okay. So another effect of global warming is that we have these warmer oceans, like I said. And so warmer oceans, just like in an El Nino event, warmer oceans are going to decrease upwelling. And so upwelling is an important source of nutrients. You have that, right, the nitrogen, the phosphorus, that probably should be potassium there, not another nitrogen, right, iron. So all of these macronutrients and micronutrients are coming up from these upwellings and feeding the phytoplankton. If they don't have these nutrients, then their populations will decrease. And so that will decrease their ability to remove the carbon dioxide through photosynthesis. And so this is another positive feedback loop. We also have ocean acidification, and so surface water dissolves carbon dioxide, and so carbon dioxide dissolves into water to form carbonic acid, and this carbonic acid lowers the pH of ocean water. And so when it lowers the pH of ocean water, not only does it cause the cells to actually start breaking down, it also decreases the abilities of corals to actually make those calcium carbonate shells. And so remember, we've talked about before that those calcium carbonate shells are really important carbon sink. Carbon sink being anything that actually takes in carbon and sequesters it or holds it in and keeps it out of the atmosphere. And so, right, this can actually upset ocean food webs and reduce the rate of carbon dioxide removal from the atmosphere. Changes in precipitation and weather extremes, and so you have a shift in precipitation patterns. Again, we're talking about climate change. So the climate is changing. It's altering how often precipitation patterns are happening and also the distribution. And so you have extreme heat waves and drought and heavy rains and flooding in places where they weren't happening before and are ill prepared to deal with them. And so, through the lab that you guys did, we also have increased hurricane and typhoon frequency, and so the strength is increased due to these warming oceans, because that is the cause of a hurricane, is that you have warm water, and that will feed into the hurricane. So not only do we have increased frequency, but increased strength. Again, we're going to stop so that we can make a new video.